coding 112 question path sum. Given a binary tree and sum determining if the tree has a root to leaf path, such as adding up all the values along the path equals the given sum. A leaf is a node with no children, so 7, 2, 1 are leaves. Given the below binary tree and the sum is 22, and the output should be true because there is a root to leaf path 5, 4, 11, 2, which sums at 22. Okay, so the interview the question is pretty straightforward. Just given a binary tree, specifically given the root of the binary tree, you should output a Boolean. So you should output whether true or false. And if it's returning true, then there is a root to leaf path. So to solve any kind of like tree problem, maybe the best way is to do it recursively, because just think about it, when you do the binary tree, it's just really hard to iteratively solve the problem. So you always kind of trying to find recursive solution. So our function has path sum, so it has a node passed in and a sum. So basically we can use the function and recursively call the function for its children node. And we just have to kind of substitute the sum to something else. So for example, if the sum is 22, at this position, we have 5, so we have to find a path that is adding up to 22 minus 5, which is 17, right? So our goal is to find some number that adds to 17. And because we have 4 here, so 17 minus 4 is 13. So our goal is to find a number that is 13. And because we have 11 here, we will try to find 13 minus 11, which is 2. So, and we have 2 here. And because 2 is also the leaf, so there we should output like true. So basically, let me just code it up, and hopefully you can understand it along the way. So first of all, we have to check some corner cases. So if root is null, so basically if root is empty, not root, return false. So no matter what kind of sum we have, if there is no such root exists, we have to output false, because there won't be no path, right, for null node. And that's our corner cases. And our sum should minus equal to root dot value. Again, at each step, we're kind of subtracting the value of that node from our sum, right? Okay. After we do that, for recursive function, we have to first have a base case. So our base case will be we are at the leaf node. So if we're at the leaf node, so meaning that root dot left, not root dot left, and not root dot right. So the root, so the node doesn't have a left node or nor a right node. In that case, it's a leaf.